Hello, this is Mr. G. In today's video, we're going to start talking about factoring, specifically factoring with a GCF. Before we get into what a GCF is, let's make sure we all understand what factoring a polynomial actually looks like. Factoring a polynomial is actually the same exact thing as factoring a number. Like if I gave you the number 8, you could say, all right, 8 equals 4 times 2. That's factoring. You rewrote a bigger number as the product of two smaller numbers. That's exactly what we're going to be doing with polynomials. It's going to look a little uglier, I'll admit, but it's the same exact thing. We're going to be taking a bigger polynomial and writing it as the product of two or more smaller polynomials. Now, one important thing to remember here, we can always check our work. Just like we can double check that 8 equals 4 times 2 by actually multiplying 4 times 2 and seeing that we get 8, we can do the same thing with our examples today. We can take the polynomials we got in our answer at the end after we factored, multiply them together, and make sure we get back to the original polynomial they gave us in the question. GCF stands for greatest common factor, and the reason we're talking about this form of factoring first is because it's always the first type of factoring we should try. Anytime the directions say factor, the first thing we should look for is a GCF. One of the nice things about a GCF is that it doesn't matter how many terms our original polynomial has, we can always look for a GCF. We can look for a GCF if it's a binomial and has 2 terms, if it's a trinomial and has 3 terms, or if it has 4, 5, 6. It doesn't matter how many terms that there are, we can always look for a GCF. One of the most important things to remember when we're factoring a GCF is that it's the opposite of the distributive property. When we distribute, we're multiplying into a set of parentheses. But when we're factoring a GCF, we're dividing out in front of the parentheses we're creating. That might seem a little confusing now, but hopefully it'll make more sense as we go on. Let's take a look at how this looks in some examples. In example 1, it says factor 15x squared plus 20. The C in GCF stands for common, so we have to figure out what our two terms have in common. There's no common variable. The first one has an x squared. The second term doesn't have an x at all, but we see a 15 in a coefficient and a 20 in a constant. There's a GCF between 15 and 20. We can divide both of them by 5. Remember, we're going to do the opposite of distributing here. Instead of multiplying into the parentheses, we're going to divide that 5 out in front of parentheses we're going to create. First, we write 5 since that's our GCF. We always write our GCF first in our answer. Now we just have to do our division. 15x squared divided by 5 becomes 3x squared, and 20 divided by 5 becomes plus 4. That means 5 times 3x squared plus 4 is our final answer. And we can double check ourselves. If we do 5 times 3x squared, we get 15x squared, and if we do 5 times 4, we get 20. So we know that we did this correct. A GCF doesn't just have to be numbers though, as we'll see in example 2. It says factor x to the 4th minus 8x to the 3rd plus 4x squared. If we look at our numbers, we're not going to see a useful GCF. There's a 1 for a coefficient here, so we've got 1, -8, and 4. I guess we could divide them all by a positive 1, but that's not going to change anything, so that's not really that helpful. But remember, the C in GCF stands for common. What do all of these 3 terms have in common? They have a common variable of x, so that's what we're going to divide by. The question is, what's the power of x that we can divide out? What's the biggest power of x that we can divide all of our terms by? And the answer is x squared. X squared is the biggest power of x we can divide by. And if that doesn't make sense, just think about it this way. Let's say we tried to divide by an x to the power of 3. If we try to divide this 4x squared by an x to the 3rd power, there won't be enough x's in the numerator to divide out because there's only a power of 2 up there. If you're still confused, here's a nice easy trick. Whenever there's a common variable, we're always going to divide out by the smallest power we see. Now we just do the opposite of distributing. Instead of multiplying in, we take our GCF of x squared and divide it out in front, which gives us x squared times x to the 4th divided by x squared becomes x squared because we subtract our powers. -8x to the 3rd divided by x squared becomes -8x. And 4x squared divided by x squared becomes 4. Now we can check to make sure we did this correct. And to check, all we have to do is distribute that GCF back in and see if we get our original polynomial. X squared times x squared is x to the 4th. X squared times -8x is -8x to the 3rd. And x squared times plus 4 is plus 4x squared. Now we're sure we got our answer correct. Next up, it says we've got a factor 8x to the 3rd plus 4x squared plus 12x. The directions say factor, so we always have to look for a GCF first. As far as the numbers go, we see an 8, a 4, and a 12. That means we can divide them all by 4. But that's not all they have in common. They also have a common variable. So we have to divide by that common variable of x. And remember, we always pick the smallest power of x. Since the smallest power we see is x to the 1, that's what we divide by. So that makes our GCF 4x. We take that GCF and divide it out in front. 8x to the third divided by 4x becomes 2x squared. 4x squared divided by x becomes x. And 12x divided by 4x becomes 3. That's our final answer. If we wanted to be absolutely sure, we could double check ourselves by distributing. We could say 4x times 2x squared is 8x to the third. 4x times x is 4x squared. And 4x times 3 is 12x. That means we're 100% correct. This problem is done. So we've covered the main types of GCFs. We saw a GCF that was just a number, we saw a GCF that was just a variable, and we saw a GCF that was a combination of a number and a variable. But there's two other weird sort of special cases I want to cover with you before we end this video. Example 4 says we have to factor x minus 7. Now, a lot of you at home might be looking at this and saying, well, there's nothing in common. There's no common variable because this second term doesn't have an x, and there's no numerical GCF because this just has a 1 in front. And that's not wrong. Most math teachers would look at this and say, yeah, there's no GCF, there's no need to factor. But there are some situations that arise in math where it's beneficial to be able to factor something that looks like this. The GCF we're going to choose is a -1. So we're going to divide both of these terms by -1. We bring that -1 in front, and then we just divide. X divided by -1 is just -x, and -7 divided by -1 is +7. This answer looks a little clumsy to me, so I'm going to rewrite it. I'm going to rewrite this as just negative times, because we don't really need that 1 there, and then I'm going to change this order. I'm going to put the +7 first and the -x second. I think that looks a little bit nicer. Now, a lot of you at home are probably thinking, well, wait a minute, how is this any better than what we started with? I'll admit, it doesn't look like it's much better at all, but there are some situations in math where it's beneficial to be able to take something like x minus 7 and rewrite it as -7 minus x. So as you advance in your mathematical careers, just remember that sometimes there's some benefit to dividing by a GCF of -1. This is our last example, and it is a weird one. It says divide 6x to the third plus x squared minus 2x plus 3 by a common factor of x. What makes this problem so weird is that if I was looking at this, I would say, well, there is no common factor of x. There is no common variable because this 3 doesn't have a variable at all. But they're not just saying factor. They're specifically saying divide by a common factor of x. So that's what we're going to divide by. Let's see what happens. Since we're dividing all the terms by x, we have to put an x in front. And let's see what we get when we divide. 6x to the third divided by x is 6x squared. X squared divided by x is x. -2x divided by x is -2. And now we get to the part that's a problem, because 3 divided by x, we can't really simplify that. There's no x in the numerator to cancel out with the x in the denominator. So, since we can't simplify it, we just write it as plus 3 over x. So that's what we get when we divide this polynomial by a common factor of x. I'll admit, it looks kind of ugly. I don't know if it looks any better than what we started with, but they told us to divide by a common factor of x, and this is what we get when we do that. This is definitely a special case type of problem. I don't know if a lot of you watching at home will see a problem like this, but just in case any of you do, I want you to be ready for it. I hope this was helpful. As always, if you have questions, please feel free to put them in the comments below, and until next time, enjoy the rest of your day.